Hi guys, today I would like to discuss with you the possibility of teleportation. We are touching on one of the most frequently asked questions: is teleportation possible? We know a lot about teleportation from science fiction movies, when characters use a specific transportation equipment to travel fast for long distances. For many years, scientists and researchers around the globe are trying to answer this simple question. However, no answer has been found yet. I propose you to look at teleportation from navigation point of view. Navigation is a process of movement from one point to another in defined space. In this case, teleportation should use some navigation methods, or could be a new one. Teleportation is exactly a transportation task. More often, teleportation is the most effective transportation approach. Let's consider a simple example. If we would like to move from Frankfurt to Los Angeles, we use an airplane as the most effective transportation vehicle. During the flight, pilot selects the most effective trajectory of the flight to use benefits from weather and wind distribution over the whole flight path. In any case, this traveling along an airplane trajectory takes about 12 hours to reach LA and about 6,000 miles to move. Now you know, navigation is a process of movement from one point to another point in defined space. Now let's define. Teleportation is also a process of movement from one point to another, however with no trajectory usage in defined space. It means we've been in Frankfurt and then clap and we are in Los Angeles. Does it possible to travel with no trajectory? I could tell you yes, if you look at this problem from navigation point of view. To show you the possibility, let me introduce the basics of geography. We use angles of latitude and longitude to define user position in space. Latitude is an angle between the line connected with user location and equatorial plane. Latitude is in range from minus 90 degrees at the South Pole up to 90 degrees at the North Pole, with 0 degrees at the equatorial plane. Longitude is an angle between line connected with user location and prime meridian plane. Longitude is in range from minus 180 degrees to plus 180 degrees, with 0 degrees at prime meridian. Coordinates of latitude and longitude specify point location at the surface of our planet. Of course, we could add altitude from reference ellipsoid shape to define any location in three-dimensional space. Altitude could be geocentrical when is counted from Earth's radius side, or could be geodetic when is tangential to the ellipsoidal surface. This map is not Cartesian. It is a projection of latitude and longitude data into some surface which then have been opened in particular form. Thus, we represent spherical coordinates in Cartesian form. Actually, these two dimensions, latitude and longitude, are placed into the shape of ellipsoidal model. And to travel with no trajectory in latitude-longitude dimension, we could just drill of globe tangential to ellipsoidal shape. Thus, where is the Europe? Okay, it is here, Frankfurt. That's why we need to drill from Frankfurt point and drill from LA point. Two tangential holes meet each other somewhere underground. Traveling along this underground space does not give any trajectories in latitude and longitude. And yes, we could say traveling in this way is teleportation in two-dimensional space of latitude and longitude, because there is no trajectory between these points. Very important here that we could move our trajectory to the third dimension, altitude. And altitude will be decreasing with the time until we reach another cave in the center of our planet, which move us to the Earth's surface at the destination point. Therefore, theoretically, teleportation in latitude-longitude space is possible, which means traveling with no trajectory. A Cartesian reference frame is highly useful today. However, the nature of our world could have some disturbances. These disturbances could be used to move our vehicle traveling path to another dimension, for example, altitudes. Yes, this example works for two-dimensional teleportation, and of course could be transformed into three-dimensional. And what we need is just to find a fourth dimension to move all our traveling paths there. Thank you.